today we are going to study chemistry subject, and this is session number 10 belonging to the same chapter, which is aliphatic hydrocarbon. Now in this session number 10 we are going to get emphasize upon the preparation methodology of acetylene, or the most probably alkyne I can say. Now in session number 9 we have studied or gone through the alkynes, the members belonging towards the alkyne, what was an alkyne, and up to 5 members we have been studied. So as we know, the alkyne are aliphatic unsaturated hydrocarbon with general formula CnH2n-2. So that is the general formula for the alkyne, and the alkyne should possess at least one triple bond into it, at least one triple bond. That's what it is making to convert into the unsaturated hydrocarbon. Okay, now let's go towards the first preparation methodology. How should we prepare the alkyne by taking certain technique? Now the first preparation technique is that we need to prepare the acetylene by taking an important ingredient or the reactant so called as calcium carbide. So if I take calcium carbide as a one important reactant, if that calcium carbide is going to get react with a second reactant, the product should get as an alkyne. Okay, so that is the meaning of the word, the preparation method. Okay, preparation means to prepare the alkyne from another 2 reactant, and the 2 reactant will be depend upon the method or the techniques we are going to adapt over here. So let's begin over here with the first preparation methodology, that is preparation of acetylene from calcium carbide. Okay, now calcium carbide will have the formula CaC2. So this is the formula for molecular formula for calcium carbide. So when this calcium carbide, now let's write down the point over here. When calcium carbide is treated with water, it yield alkyne, means basically the ethyne, I can say the word ethyne, or the common name for this ethyne is acetylene. Okay, so first we need to manufacture or produce acetylene by the treatment of calcium carbide with the water, right? So how this will be going to get yield out, let's see over here. It's very simple, children. What is happening over here? See, the calcium carbide will be going to get treated with the water. Now the calcium carbide will have a structure in this manner, right, with the triple bond between this carbon and one calcium will be going to get attached in this manner, and it will go this calcium carbide. So this is the structure of what? Calcium carbide. So when this calcium carbide will be going to get combined with 2 water molecules, so I am going to write this water molecule in this manner. So what will happen, children, over here is that this 2 hydrogen will going to get bind up with this 2 carbon, and this 2 hydroxyl ions which are there, they will going to get combined with this calcium. I repeat once again, if I am writing 2 as a coefficient in front of hydrogen and hydroxyl, we know that 2 hydrogen atom is there and 2 hydroxyl ion will be there. This 2 hydrogen atom will go and get combined with this 2 carbon atom. between the carbon-carbon triple bond, wherein this calcium will go and get combined with these two hydroxyl ions. So thereby I am going to yield a product so called as CH triple bond CH. Now what is the meaning of this word CH? The structure formula which I had written over there, what is the meaning, what is the name for that? Here 2 carbon is there, so 2 carbon oriented alkyne is nothing but it is ethine. So this is how you are going to manufacture or prepare ethine, when this 2 carbon will going to get attached with this 2 hydrogen, and this calcium will going to get combined with this hydroxyl to form a byproduct which is called as calcium hydroxide. Calcium hydroxide, and this 2OH I am writing in this manner as in the form of a subscript. Okay, so this is the thing wherein how the reaction will be going to take place. Now let's go towards the another methodology for the preparation of alkyne. So the next one will take the dehydrohalogenation of vicinal halide. So next methodology or second preparation is halogenation of vicinal dihalide. So now this is the second method from which we need to prepare the alkyne. So let's understand this topic, what is written on the board. D means what? Removal. Hydro means yes, hydrogen. Halo means halide group, X group. Now do you understand by the word vicinal dihalide? So what do you understand by the word vicinal dihalide? Dihalide means 2 halo group, right? 2 halogen group will be going to get attached between the carbon-carbon atom, and those 2 halo group will be going to get attached in the adjacent manner of the carbon atom. I repeat once again, vicinal means what? If 2 halogen groups are going to get attached between the 2 carbon atoms in such a way that these 2 halo groups are going to get attached to the adjacent carbon atom. So this is the meaning of the word vicinal. Vicinal means the 2 halogen group are going to get attached to the adjacent carbon atom of the carbon-carbon bond, right? So vicinal dihalide. Dihalide means what? Di means 2, right? So 2 halo group or the halogen groups are going to get attached to the adjacent carbon atom. So what is the meaning of this topic? Removal of halogen from where? From vicinal dihalide. Understood the topic? So you are going to remove the hydrogen, halogen, these 2 important atoms to be removed out from the vicinal dihalide, right? So by taking this methodology, we need to obtain the alkyne from there. Okay, so let's understand this topic. By taking that topic, it becomes very simplifier for to prepare the alkyne over there. Okay, so let's take over here direct example. Now if this is the molecule wherein I am writing on the board, see, now here 2 halo groups need to be get attached to the adjacent carbon atom. Now we need to look after for the valency as well. This carbon is attached to the 2 hydrogen atom. So 2, 3, 4. Here also 2, 3, 4. Right. So the name of the compound is 1, 2. Aliphatic nomenclature for this. 1, 2 dibromoethane. D should be capital actually. Dibromoethane. Right. So what is this molecule or the most important reactant which I had been written on the board? This is vicinal dihalide. right? So two halo groups, the two halo groups has been attached to the adjacent carbon atoms, right? So thereby this is the vicinal dihalide. Now from this vicinal dihalide we need to remove hydrogen, halogen to yield the alkyne over there. Now this reaction will be going to take place in presence of potassium hydroxide, caustic soda, right? So in presence of this potassium hydroxide, this reaction will be going to take place. So here what will happen here is that the halo group need to be removed out. Yes, the halo group will be going to get removed off. Apart from that, the hydrogen group should need to be removed off, isn't it? Right? So if the halo group is going to get removed off, so here how the reaction will be going to take place? Let's write down. So this CH2. Now here the hydrogen is also going to get removed out. The moment the hydrogen is going to get removed off, the bond breaking will be going to take place, right? So okay, I'll write in this manner, it becomes easy over here. Okay, let's write down in this manner. Now if this hydrogen is going to get removed off, this bond will shift over here, right, to form a double bond. And CH, one hydrogen is left along with one bromine, right? And this bromine, when it will break the bond over there, it will take the bond along with it. Understanding my point? It will take the electron pair from that bond towards it, because since it being highly electronegative, it will take the electron along with that when the bond is broken down. That is the mechanism part. Okay, here the hydrogen won't take the bond along with it, so the bond will be going to get shifted over here to form a double bond. Now the halogen and the hydrogen group, which has been removed from the vicinal dihalide, where it will go? It will be going to go and get combined with this potassium hydroxide, right? So this bromine atom will go and get combined with this potassium to form what? Potassium bromide, correct? Whereas this hydrogen will go and get combined with this hydroxyl to form a water, correct? So here what is happening, children? The bromine ion will go and get attached with this potassium, wherein the hydrogen atom will go and get attached with the hydroxyl to form a water. And the product which has been formed over here, the name of this product will be vinyl bromide. Okay. This vinyl bromide which has been formed over here has a main product. It will carry on further for the next step. Now children, this is two-step reaction. Totally it is two-step reaction. In first step, it will lead to the formation of vinyl bromide. This vinyl bromide will undergo further reaction with the soda amide. Okay, so this vinyl bromide will going to get react with the soda amide, NaNH2, right? So what is we need to yield over here? We need to yield an alkyne. Now if I need to yield an alkyne, the 2 carbon is there. You need to apply your mind over here. If 2 carbon is there, obviously it will yield ethyne, because the molecular formula for the ethyne was C2H2, right? So if 2 carbon is there, 2 hydrogen is already there combined with the first carbon, and 1 hydrogen is combined with the another carbon, it need only 1 hydrogen towards it, right? So thereby the reaction, the ethyne will have the molecular formula in this manner it is, right? The ethyne will have CH triple bond CH, right? Not CH2 is not the molecular formula for it. So if this is the condition for the ethyne, so you know that 1 hydrogen is there already here, another hydrogen will be over here. So that means 1 hydrogen from here need to be get removed off. This is the molecular formula for the ethyne, acetylene, correct? And we need to prepare this ethyne as an alkyne over here. So what will be going to happen over here, children, is 1 hydrogen from here and the another hydrogen is going to remain as it is. So only 1 hydrogen this bromine, if I removed off, then I am going to prepare over here ethane over there, right? So for that reason what we need to do is that here the hydrogen from here, when it is going to get removed, one hydrogen, so this one hydrogen will go and get combined with this amine to form what? Let's prepare first byproduct to prepare an ammonia. One hydrogen will go and get combined with this amine to form ammonia, which is NH3, right? So this bromide, which is creating a problem over here, it will go and get combined with this sodium, correct? And whatever is going to get left over here is CH, triple bond CH, because once the hydrogen is removed or abstracted from here, it will leave the bond over there itself, and that bond will create a triple bond over here, right? So let's write down the product over here. So what is happening? CH, one hydrogen has been removed and gone and attached to NH2 to form NH3, right? And it will lead to the formation of triple bond, then CH. Now what about the bromide? Now this bromide ion will go and get combined with the sodium to form sodium bromide, and this hydrogen gone and got combined with the amine to form ammonia gas. So what is the name of this? The name for this is ethane with the molecular formula C2H2. C2H2, right? So this is how the structure will be there for ethane. Okay, and a name for this, common name for this is acetylene. So this is two-step reaction, very important reaction for the preparation of alkyne from vicinal dihalide through a process called as dehydrohalogenation. D means removal, hydro means hydrogen, halo means halogen group. So you need to remove the hydrogen, halogen from the vicinal dihalide, and this is vicinal dihalide where two halo group will be going to get attached to the adjacent carbon atom of the aliphatic hydrocarbon, right? So in this manner, one halo group will be going to get removed from one carbon atom, and the another hydrogen atom will be going to get removed from the another carbon atom, and thereby we are going to yield certain intermediate whose name is vinyl bromide. This vinyl bromide will be going to go and attach or combined with soda amide. The name for this is soda amide to form ethane, ammonia gas, and then sodium bromide. So this is how the reaction will be going to take place. Now let's go towards the third type of preparation method, right? So that is also the dehalogenation process of tetrahalide. Children, now we'll go towards the next topic. The name of the next topic is dehalogenation of tetrahalides. So remember, we are studying the preparation method, right? So what we are preparing? We are preparing the alkyne by taking certain two important reactant depending upon the name of technique. So the name of technique or method is dehalogenation. Now what do you understand by the word D? D means removal. Halogenation, halo means what? Halogen. So you are going to remove the halogen from tetra means four halide oriented aliphatic hydrocarbon, right? So you are going to remove the halogen groups from the tetrahalides, right? So here the tetrahalides oriented reactant would be, we need to write down in this manner. So this is the two carbon containing compound in which 4 halo group will be going to get attached to it, right? The 4 halo group will be going to get attached in this manner: 1, 2, 3, 4, right? So the name of this reactant would be 1. At first carbon 2 bromo is there, so 1 1 1 for one bromo, 1 for another bromo, then 2 for another bromo, third bromo, 2 for another fourth bromo. So in this manner the IUPAC nomenclature would be. So how many total halo groups are there? How many total similar groups are there? 4. the prefix would be tetra. Tetra bromo. And what is the name of the parent alkane? Why am I supposed to take alkane over here? Because here it is a single bond. So thereby it is an alkane. So between carbon you can see a single bond is present. So therefore its name would be ethane, because 2 carbon containing parent alkane is ethane. Okay, so 1,1,2,2 tetrabromoethane is the IUPAC nomenclature for this given tetrahalide oriented organic compound. Now when this is treated with the 2 zinc metal, okay, so what is happening, children, over here? So all the bromo groups should be removed out, right? So if this bromo group is removed out, here 2 carbon and 2 hydrogen will be going to get left out to yield the ethane, right? So the byproduct wherein it will be going to get formed is that 2 zinc metal will take out all these 4 bromo atom to form the product so called as zinc bromide. So totally 2 zinc is there, right, and Br2. This is written in this manner. Okay, so totally you can see 2 2s are 4 bromo, and the remaining important product what is going to get formed is ethane, right, or acetylene. So this is how the preparation of alkyne will be going to take place from tetrahalide oriented organic compound in which dehalogenation, here dehydrohalogenation is not taking place. So if the dehydrohalogenation is given in the topic, that means removal of hydrogen and halogen will be going to take place from that particular reactant. But the topic only is saying only the removal of halogen group is going to take place. So whatever the 4 halogen groups are there, that will be going to get removed by the second reactant to form an alkyne over there. Now let's go towards the next formation technique. Now until this time whatever we have been studied, first one is the preparation of alkyne from calcium carbide. Second one was dehydrohalogenation of vicinal dihalide, from that also we prepared the alkyne. Now the third one was dehalogenation of tetrahalide. So these are the 3 important methodology to prepare the alkyne. So these are the preparation method. Now henceforth we'll begin with the formation or the chemical reaction. In turn I can say the chemical reaction in which the alkyne will be used as one of the reactant and the another reactant depend upon the method and the product it will yield something else. Right? So preparation is different and chemical reaction is different. Chemical reaction in which one of the reactant will be the alkyne. Okay, so now let's go towards the another topic, formation of metal acetylide. You need to prepare metal acetylide by taking one of the important reactant over there as the alkyne. So alkyne is need to react with a certain reactant to form the metal acetylide. Now the second reactant which makes to yield the metal acetylide is the Tollens reagent. Okay, so with the help of that Tollens reagent we need to prepare the alkyne over there. Okay, so the Tollens reagent is also called as ammonical silver nitrate. Okay, it is also called as ammonical silver nitrate. Now what does this Tollens reagent have the molecular formula? That let's understand that. Tollens reagent. With the help of this Tollens reagent or ammonical silver nitrate we need to yield the metal acetylide. Okay, so what is this the Tollens reagent is? It has the molecular formula in this manner where the ammonia group is also there and you can see OH group is also combined over there, right? So this is how the Tollens reagent has the molecular formula. You can see over there which is written over there, right? So this Tollens reagent when it is treated with alkyne, you can see the triple bond is there between this carbon-carbon. So here 1, 2, 3, 4, it is satisfied. So never make mistake by adding one hydrogen over here. Okay, so with this carbon 1, 2, 3, 4, right? Done. So when this alkyne is treated with the Tollens reagent, it will obtain the metal acetylide. So how it will obtain the metal acetylide? Let's see over here. This alkyne group is there, no? Until this carbon, second carbon, this will go and get combined with the silver. Silver is what? It is a metal. So metal acetylide means what? Metal will go and get combined with the alkyne group. And this is what basically the alkyne, and the example what we need to take is acetylene, right, in order to yield metal acetylide. So I am just explaining you first the general reaction. Okay, so this will go and get combined with the silver to form a white precipitate, which is written in this manner. Okay, this is metal acetylide. Okay, metal alkyne I can say, and then plus here the hydrogen which has been removed from here, it will go and get combined over here with the ammonia. Okay, or first, okay, this hydrogen, okay, in fact this hydrogen will go and get combined with this hydroxyl to form water, and this 2 ammonia will be going to get liberated as the ammonia gas. Very simple it is, children. What is happening? Until this second carbon atom, this entire group will go and get combined with the silver to form metal alkyne basically, because since I am taking the general formula or general reaction, then this hydrogen will go and get combined with the hydroxyl to form water, and this ammonia will be going to get liberated in the form of ammonia gas. Now what they had given over there is the formation of metal acetylide. So if I need to form a metal acetylide, we need to take an alkyne which is acetylene. Okay, so if you combine with the acetylene, we need to form that product over there. So let's take an acetylene. So this is the general reaction simply. Now if I take the example which is having acetylene, acetylene is having a molecular formula in this manner, because metal acetylide I need to form, right? So this is going to get combined with 2 molecules of Tollens reagent. Now this is ammonical silver nitrate. So this NH3 twice plus OH minus. So this is what? This is the Tollens reagent. Tollens reagent. So acetylene, when it is combined with the Tollens reagent, what will happen, children? Here, as I said, the 2 hydrogen, now whatever the 2 hydrogen are there combined with this carbon-carbon triple bond, this will be going to get replaced out, right? This will be going to get replaced out with this 2 silver metal, right? So let's write down this first as a product. So triple bond C Ag Ag. What I did? The 2 hydrogen atom of acetylene is replaced with the 2 silver metal. And what we obtained over here, the name for this is metal acetylide. Acetylene, right? It is acetylene, so the name will be acetylide. So the name for this is silver acetylide. Silver acetylide. Okay. Now what about the byproduct? What about the byproduct? Now this 2 hydrogen which is there, this will go and get combined with the hydroxyl to form a water molecule. Yes, but how many water molecule it will yield? That is the question over here. Now you can see here totally 2 hydrogen, and this is third one. Okay, now okay, you can see here 2 is written in the form of a coefficient. So in this form 2 oxygen and 2 hydrogen is there, right, wherein 2 hydrogen is already present over there. So you can see totally 2 plus 2, how much? 4. So it will yield 2 water molecules. Yes, you can see over here. Here 2 hydrogen, here 2 hydrogen. So totally 4, and how many oxygen is there? 2 oxygen. So 2 water molecule is formed along with it. Now how many ammonia? 2 2s are 4. So 4 ammonia molecule will be going to get escape. Ammonia will be going to get escape in the gas form, right? So this is how the silver acetylate will be going to get precipitate in the white form, right? So white precipitation of the silver acetylide will be going to get formed. So what is happening over here, children? It's very simple, but it's little tricky also. When alkyne is treated with the Tollens reagent, it will yield the metal alkyde with the formation of ammonia and the water. Now in this you are going to obtain a metal acetylide. So that time acetylene will be going to get combined with the 2 molecules of Tollens reagent. So whatever the 2 hydrogen atoms are there in the acetylene, that will be going to get replaced by the 2 silver metal to form a silver acetylate. And the remaining hydrogen, 2 hydrogen will going to get combined with this 2 hydroxyl ion to form 2 water molecule and 4 ammonia gas, right? So this is how the formation of metal acetylide will be going to take place with the help of alkyne and the Tollens reagent, and the silver acetylide will be going to get precipitate. Okay, so this is the reaction which is taking place. Now we will study the next process or the chemical reaction which is called as the ozonolysis process. Now in this, the ozone molecule plays an important role over here. When an alkyne is treated with the ozone, which is O3, it will form the alkyl ozonoid. It will form the intermediate which is called as alkyne ozonoid. This alkyne ozonoid on reductive cleavage with the help of zinc and water, it will yield diketone, and the diketone on oxidative cleavage, it will yield the carboxylic acid. So whatever the statement I had said to you, just let's write down in the form of a chemical reaction, then you'll understand everything in a very step-by-step manner. Okay, what I said, ozonolysis is the process when alkyne need to get reacted with the ozone first. Okay, so let's take an alkyne. So let's understand this reaction first with the general reaction. Which topic we are reading? Ozonolysis. Okay, so in this reaction, first the alkyne need to get react. Now this is an alkyne and this is getting treated with ozone, which is O3, to form an intermediate called as alkyne ozonoid. Okay, so the intermediate will be going to get formed in this manner. You can see over here, I am writing down on the board. So this is what? This is the alkyne ozonoid. Now this alkyl ozonoid on further reaction with zinc dust and water, it will undergo reductive cleavage. It will undergo reductive cleavage to form a diketone. Now how come diketone will be going to get formed? Let's first write down the byproduct. Now here the water is there, no? It will take this oxygen to form hydrogen peroxide. Okay, then the remaining thing, what is remaining over here? Carbon oxygen. So this will be going to get combined in this manner to form a diketone. Diketone means what? 2 carbonyl carbon is present in one ketonic form, right? This 2 carbonyl carbon oriented compound will be present in a similar functional group of ketone, right? So dione, I can say. So this diketone oriented product which has been formed, it will undergo further oxidative cleavage. Oxidative cleavage means it will undergo the oxidation process to form the carboxylic acid. So this is what the general reaction says. Okay, So here you can see the alkyne was treated with the ozone O3 to form the alkyne ozonoid. This alkyne ozonoid, on further treatment with the zinc dust and water, it will lead to the formation of diketone and the hydrogen peroxide. This oxygen will take away by the water to form hydrogen peroxide. And the oxidative cleavage, when this diketone is further undergoing the oxidation process, that time it will lead to the formation of carboxylic acid. This is the carboxylic acid functional group. Carboxylic acid. Okay, so this is how the reaction will be going to take place. Now let's take an example. So if I took one example, one or two example, that time it becomes more simplified for you guys. So let's take an example here one by one. So first example will take an alkyne of acetylene and second will take an propyne. Okay, so if I take an example, first one, acetylene, example number 1, acetylene or ethine. So when this ethine is treated with the ozone, now this is ethine, when it is treated with ozone, which is O3, it will lead to the formation of ozonoid, right? Ethine ozonoid. So how that ozonoid will be going to get formed? Let's write down. So this is the ozone. Okay, 2 carbon, 2 hydrogen, I'll write down in this manner first, and yes, this is ethine ozonoid. Ethine ozonoid or ozonoid also you can write down, no worries. Now this, on further reaction with the zinc dust or water, ethine ozonoid, which has been formed as an intermediate, since it being very unstable, it will undergo further reaction with the zinc dust and the water to yield a diketone kind of product, right? So here the 2 oxygen, now here what will happen, the zinc will take away the oxygen or the water molecule will take away the oxygen to form the water molecule. That is another criteria. So one oxygen will be going to get removed out by removing by taking out the zinc from the oxygen. So what will happen, the zinc will remove out the oxygen to form the zinc oxide, and the 2 oxygen will be going to get combined with this 2 carbon to form a product which is called as glyoxal. Glyoxal. So this is the name of the product, which is nothing but called as a glyoxal. Okay. So what is happening over here? The acetylene or ethine, when it is treated with the ozone, it will form ethine ozonoid. This ethine ozonoid, on further undergoing reductive cleavage, this is nothing but called as what it is process? Reductive cleavage in presence of zinc or water molecule to form a glyoxal. Now this glyoxal, on further reaction with the oxidative cleavage, it will lead to the formation of carboxylic acid. The carboxylic acid formation you don't need. The reaction will be going to end up only near the diketone, right? So this is the general reaction, and that one was the example. Now let's take one more example. That time it becomes more easier for you guys to understand. So this is how the reaction will be going to take place. Now let's take the another general example. Example over here. So in this, the alkyne will make a different one. There the ethine we used. Here in the second example we will utilize the propyne. Okay. Now second example, I am going to utilize the another alkyne, which is propyne. So what is this? This is propyne. So when the propyne is treated with the ozone, yes, it will lead to the formation of ozonoid, propyne ozonoid, right? So this propyne ozonoid is written in this manner. This oxygen will be going to get combined with the carbon-carbon triple bond. So methyl group will not going to get participate, right? The addition of oxygen from the ozone molecule will be going to take place between carbon-carbon triple bond. Okay, so thereby the product, the intermediate I can say, will be going to get formed in this manner. And the name of this ozonoid oriented molecule is propyne ozonoid. Okay, now this propyne ozonoid, on further reaction with the zinc dust and water, it will undergo reductive cleavage to yield the diketone. Okay, so how this diketone will be going to get formed? Now this one oxygen will go and get combined with this zinc to form zinc oxide in turn, or you can say the water will go and get combined with the oxygen to form a peroxide, hydrogen peroxide. So the remaining one, CH3C, this carbon will have this oxygen, or this carbon will have this oxygen. It's up to you. Like this carbon will have this oxygen, and this carbon will have the another oxygen to form a carbonyl carbon over there, right? So this carbon will have this oxygen, and the another carbon will have the another oxygen along with the hydrogen. The zinc will take away the one oxygen to form zinc oxide. That is zinc oxide. The name for this is, you can see one functional group, RCOH. So what is the name of this functional group, by the way? The name for this functional group is aldehyde, right? Now here you can see two carbonyl carbon is there, right? So one carbonyl carbon is extra over here. So this is 1, 2, 3. If I need to give the nomenclature for this organic compound, the functional group is aldehyde. You can see here one alkyl group is there. This is alkyl group, R group. CH3 is a methyl group, right? And COH, this is the aldehyde group. This one is the aldehyde group. This is the carbonyl carbon, which is nothing but written in the form of oxo, right? So how you will write the IUPAC nomenclature for this? So 2 at second position, oxo group is there. 2 oxo. Now if here totally how many are there? There are totally 3 carbon present over there, right? So in that 3 carbon, so the name for this kind of an aldehyde becomes propanal. Propanal means why? If from parent alkane, propane is there, E of parent alkane will be going to get removed off, and the suffix so called as Al will be going to get added, which you studied in your 12th standard, right? So here oxopropanal will be the name of this Al, not OL. If you wrote OL, that becomes propanol, which is an alcohol. Again, that is different. So Al should come, right? So at first, carbon, this is the functional group of the carbonyl carbon. This is the oxo group, which is attached to the second carbon, which is the branching one. Okay, so this is how the product will be going to get formed when the propyne is treated with the ozone to form propyne ozonoid. That will undergo further reductive cleavage in presence of zinc and water to form 2-oxopropanal, right, as the main product. So this entire process is nothing but called as ozonolysis. Okay, what it is called as? It is called as ozonolysis. Okay students, now let's go towards the another topic, which is the oxidation reaction with the help of hot chemonophore, right? Now when I talk about the oxidation means the reaction in which the oxygen will be going to get implemented to a certain product, right? The reaction which is taking place in presence of oxygen. For that reason, we need certain oxidizing agent. The oxidizing agent is nothing but the chemonophore, which supplies the nascent oxygen, the highly reactive oxygen for the reactant. Now here, whenever the alkyne, which is so called as ethyne, is treated with the oxygen, and this oxygen will be going to get supplied from, it will be going to get supplied from where? From oxidizing agent, which is called as chemonophore. Now this reaction is taking place in presence of hot alkaline chemonophore. Hot alkaline chemonophore. Now this is the alkaline medium. Potassium hydroxide is there, alkaline medium is there. In presence of hot KMnO4, it will yield a product which is called as acid. Now this acid, the bond will be going to get broken down over here to yield the carboxylic acid over here, which is nothing but called as oxalic acid. Right? Now this oxalic acid on further oxidation, right? On further oxidation, it basically going to get yield the carbon dioxide. The carbon dioxide, totally 2 carbon dioxide is there, you can see CO2, right? So 2 molecule of carbon dioxide and 1 water here, 2 hydrogen and 1 this oxygen will be going to get combined together to form water. So you can see here 2 carbon dioxide gas and this H2 will going to get combined with this oxygen to form water, right? So what is happening over here, children? The ethyne, the acetylene, when it is treated with the hot KMnO4, it will lead to the releasing of the nascent oxygen. This nascent oxygen will going to get combined with this ethyne between the carbon-carbon triple bond to form an acid. That oxalic acid on further oxidation leads to the formation of carbon dioxide and the water, right? So this is the first example for the oxidation with the hot KMnO4. Let's take the another example here, simple one, I'll write here in short form. When propine, what is this? This is the propine, right? So when this propine is treated with the nascent oxygen, right? 4 nascent oxygen that will be going to get liberated from hot KMnO4 in presence of alkaline medium or alkaline KMnO4, I can say. Okay, so that time it will yield an acid. Now basically here it will going to get yield a particular acid which is called as ethanoic acid. Now why the ethanoic acid? The reaction will be going to take place between carbon-carbon triple bond, right? So this methyl group will be as it is. So this will COOH. This bond will be going to get totally broken down to form an acid group, and this carbon will going to get combined with the number of oxygen atom which is left after this combination of 2 oxygen over here. It will lead to the formation of carbon dioxide gas, right? So this is how the ethanoic acid, or it is also called as acetic acid. CH3COH, what it is? It is an acetic acid. See here, the 4 oxygen, nascent oxygen, out of 4 nascent oxygen, 2 oxygen will go and get combined over here. CH3COOH. Now this carbon will go and get combined with the remaining 2 oxygen to form carbon dioxide. So this is ethanoic acid, or it is also called as acetic acid. Now let's go towards the another reaction, which is the addition of bromine. Now whenever the alkyne is treated with the bromine, it will lead to the formation of trans isomer of an alkyne to form a main product over there. So how that reaction will be going to take place? Let's write down. So here, if I take CH3, C triple bond CH, propine. So that time when it is treated with the bromine molecule in presence of carbon tetrachloride, right? So that time 2 bromine atoms will go and get combined to this carbon-carbon triple bond in opposite direction. Like this, in this opposite means anti-position. Towards the anti-position, these 2 bromine atoms will go and get attached to this carbon-carbon triple bond. So after getting attached, let's see how the product will be going to get formed. CH3 will remain as it is, okay. C. Now if bromine, this bromine is going and attaching on the upper side, okay. Now another bromine atom will go and get attached in the lower side. Opposite side attack of the bromine will be going to take place between carbon-carbon triple bond. And a name for this, you can see, it is going to take place in the 2 opposite side, and one more bond is there. So this is an intermediate which has been formed over here. So 1, 2, 3, 4, yes, 1, 2, 3, 4, it's correct. Now this on further reaction with the another bromine molecule, right? So here this bond will be going to get break down and all the 4 bonds will be going to get utilized to form the tetrahalo product like this, right? So in this manner all the 4 bromine will be going to get, first the trans isomer will be going to get formed and then later on all the 4 bromine will be going to get attached in that manner to form the addition of bromine in that manner. Okay, so let's take one example for that, then it becomes more simplified for you guys to understand it. So the example as such, they did not give in anything in your text, so let's wind up over there itself. Okay, so the name for this was as such trans 1,2-dibromopropene, because 2 bond is there, no? So the name is, it's very simple, 1,2-dibromopropene. Why propene? Double bond is there. Whereas now once you wrote over here, the name for the product over here which has been formed here is, this is little tricky, 1 at 1 carbon first bromo, at 1 carbon another bromo, like this. Position need to be written down. At 2nd carbon 1 bromo and 2nd carbon another bromo. The suffix will be tetra, because the 4 similar groups are there. So tetra, bromo and parent alkane. Since the parent alkane contain 3 carbon into it, the name will be propane. So this is how the product will be going to get yielded out for addition of bromine towards the alkyl. Okay, so this is again the 2-step reaction. In first step reaction, trans isomer will be going to get formed. In second step, the trans isomer will going to get combined with the another bromine molecule to form a tetrahalide oriented organic compound. So this is how the reaction will be going to take place for the addition of bromine towards the alkyne. And in the initial example, we took the oxidation of alkyne with the help of hot alkaline KMnO4, which releases the nascent oxygen to form or yield the carboxylic acid. So children, the alkyne unit has been completed. So from session number 1 till session number 10, whatever we have been studied, that was basically for the aliphatic hydrocarbon, which is covering alkane, alkene and alkyne. In alkane, the 5 first members, then after that we studied the preparation and chemical reaction. Similarly for the alkene also we stood by taking the 5 first members, the preparation and the chemical reaction. The alkyne also we have been gone through the same methodology. So this is how the entire thing will be going to get carried out in this chapter. So children, we have been winded up with this particular chapter, so called as aliphatic hydrocarbon. So next chapter soon will be going to begin. So until that time, thank you class for watching this class. Thank you so much.